Assalamualaikum warahmatullahi wabarakatuh. My name is Teguh Muhammad Ar-Rahman, GA03192. So I would like to introduce our project. So basically, we already know that the one of the most important part of mechanical component in any design is the shaft. The word shaft usually refers to rotating machine elements, usually circular in cross section, which is used to transmit power from one part to another, such as gears, sprocket, pulleys, and cams, or other devices from a machine that produce power to machine that absorb power. So our objective of this project is to design a shaft that connected to water wheel that working as a water wheel turbine. We want to design a shaft that has high tensile strength and young modulus, so it can withstand under high external force applied. Because of that, our shaft is strong enough to connecting the water wheel. On the other hand, we have to choose the most suitable material of the shaft that can deal with water and wind, so we can design a shaft that have high corrosion resistance. And we already know that the water wheel turbine is one of the most great mechanical engineering application. And one of the most important part of water wheel turbine is the shaft that connect the water wheel to the turbine. On the other hand, many cases found that the water wheel turbine do not have a great durability, because water wheel turbine designed to deal with water, so the shaft must have high corrosion resistance, and the shaft must withstand under the weight of water wheel.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq Bukhari bin Ahmad Nazri. My metric number is A159284. For my part is material selection. Okay. We choose three best material for the shaft. Which is nickel, chromium, cast iron, and also low alloy steel. Okay. For the first graph, which is price versus young modulus. The young modulus of each material are quite same. Okay, for the price, cast iron has the lowest price compared to the alloy steel, and followed by the nickel chromium, which is the highest price. Okay, for the second graph, which is yield strength versus the tensile strength. Yield strength of alloy steel is the highest among the cast iron and nickel chromium. For the tensile strength, the alloy steel has the highest tensile strength compared to the others. Okay, for the third graph, which is price versus the fracture toughness, the fracture toughness of nickel, chromium, and low alloy steel have the higher fracture toughness compared to the cast iron. So in conclusion, we choose alloy steel for the shaft material because the price of the material is reasonable with its properties, and it have high yield strength, so it can withstand the maximum force that apply before achieve the plastic deformation.
I'm Woon Tian with the matrix number of A160072, and I will be presenting the design calculation of the shaft. The rotational force of water wheel is first calculated to obtain the minimum value of moment for the shaft. Next, the shear stress of each part of the shaft with different diameter was calculated. Safety factor was also calculated, including the use strength of the shaft material, which is cast iron. Safety factor for stress raisers such as fillets also calculated, and the results concluded that the shaft is very safe to be used. Thank you.
Based on the purpose aim of this project, to study or learn the method design of a shaft in order to make the shaft fully functional. Based on our result in material part, we choose low alloy steel because of their characteristic. That is, has high yield strength, because this shaft is using only in water. In our project, there are some limitation of this project. One of the limitation, this study does not provide a complete picture of the project, because we only just learn theoretically about this shaft.
As conclusion, the shaft design is very safe to withstand the rotating water wheel since its safety factor is far higher than 100. However, to save more money, it would be better to change the material selected, greatly decreasing the cost of product while still ensuring the capability of the shaft in withstanding high loads and torques.